So with this idea of theoretical or classical probability, the first thing we should really do is more carefully define the terminology that we're working with, where we say something is an experiment if it's just any event that we're looking at that has an uncertainty attached to it, where the sample space, which we denote S, is the set of all possibilities that can occur from that experiment, and the events that we're looking at, these things that we denote E, are any subset of them that can possibly occur. So when we're talking about classical probability or theoretical probability, we assume that all of the events we're looking at are equally likely, that no one thing is more likely to happen than any other. This is sort of the probability that we would get if we assume everything works the way that it should. So, when we're going to compute the probability of something happening, in the theoretical sense, all we do is look at the number of ways that that event E can possibly occur and divide it by the total number of ways that anything within our space can occur. And this is the type of thing that we use for situations like dice rolls or cards drawn from a deck. And it's what we use if we don't really have any trial information. We're just going based on what we think is supposed to happen. So let's think about this with a brief set of examples. So, for example, if we roll a fair, standard six-sided die, let's think about some probabilities here where what we want to do is identify the probability of rolling a 4, a 7, or any number greater than 2. So in that first case, when we're talking about rolling a 4, so let's put that as the probability of a 4. What we want to do here is understand that without any information about, say, rolling the die a certain number of times to be sure that it's fair and actually has 6 sides, we assume that there's only one way we can get a 4. So if you want to find the probability of that 4, you've got that one way to get the 4, and then you've got 6 sides. So the probability of getting a 4 is just 1/6, or if you want to write that as a decimal, 0.167. For the second case, if you want to find the probability of rolling a 7, understand that this is one of those impossible events, and this is a way we can think about impossible events, because here, there isn't any way to roll a 7. So the number of ways that a 7 occurs is 0 out of 6. So the probability of that 7 is, understandably, 0. And then finally, for our last case, if you want to find the probability of rolling a number greater than 2, I'm using a little bit of a shorthand notation here, but I hope that this gets the point across. Understand that we have 4 other options: 3, 4, 5, or 6. So if we have those other things that we can possibly get on that dice roll, well, we've got 4 out of 6. Or if we prefer, we can reduce that down to 2 out of 3. Or, if we really prefer, we can represent that with a decimal, 0.667.